Good morning, math students. I'm going to show you how I would like you to do your homework. This is Chapter 1, Lesson 1, Problem Set Number 1. All right. First of all, I'm actually doing my homework in Apple Notes on my iPad. And one of the options that I have is lines and grids. And I'm going to ask it to show me some lines. All right. On your paper, I would like you to, oops, here we go. Done with that. I would like you to write the lesson up here at the top. This is 1.1. Over here, put your date. Put the date and your name. Then, now, typically you'll want to copy the entire problem. I'm going to do this, but I'm going to show you why sometimes you don't need to do all of it. Plus 700, plus 70, plus 6. All right. So this is the problem as presented. And you could probably just look at that and add it up in your head and then write down the answer. Now, if you wrote down the entire problem, don't go out here and do this endless run-on problem working. Don't do that. All right, work vertically. Now, put a blank space in between each one of your problems so that I can see where it starts and ends. And then number 2, this is the problem. Also notice that I'm putting a circle around the problem number so I can see where it starts. You gotta help me. You gotta help me. Now, this problem, I don't want to stack up and add a bunch of 9s, but look at it like this. 1,000 minus 1 plus 100 minus 1 plus 10 minus 1. Well, what's 1,110? Well, I just read it, so I'm going to write it down. And then from that, I need to take away 3. So 1107 is my final answer. Number 3. The next problem is 1 plus 0.9 plus 0.08 plus 0.004. Again, this is another one you could probably just write down once you see the problem. 1.984. All right, that's it. That's the end. Number 4, 20. I'm going to copy down the problem plus now 2 plus 0.002. So this is the problem. It's stated. Now, you could do this one in your head and not bother to write down the problem. Just write down the answer. That would be perfectly fine. But notice something. This 2 right here is in the first decimal place. And this 2 right here is in the third decimal place. So the end result is 20.202. Did you notice that? Okay. Number 5. 1. Here's the problem as stated. Well, I'm looking at this problem and I'm thinking, well, I'm going to have to stack this thing up anyway. So I'm going to start with the big number, 1, 2, 3, 4, and put it on top. Then 123, 3, let's see, 3, then 12, and then 1. And then draw a line, showing that I'm going to add. 4 and 3 is 7, 8, 9, 10. Put down the 0, carry the 1. 4, 5, 6, 7. 3 and 1, 1,370. Number 6, here is the problem as stated. 1, 1, 1, 1, plus 2, 2, 2, plus 33, plus 4. And again, I'm going to have to stack this one up. 1, 1, 1, 1, 2, 2, 2, whoops, 33, and 4. You know what? Deja vu. This is like that problem, like the one just above it. So 4 and 3 is 7, 8, 9, 10. 2, 4, 5, 6, 7, 3, 1, 3, 7, 0. Harold Jacobs often has a fair number of aha moments if you'll look for them. Sometimes they're just moments. This one was a 1 plus 1.2 plus 1.23 plus 1.234. I'm going to grab the longest number and put it on top. Remember, what's the rule for adding decimals? You got to line up the decimal place. So I'm going to start with the big number. 0.234. And again, if you did not want to write down, if you did not want to write down the entire problem and just write it down stacked up, that's fine with me. All right, then the next longest number is this one, and the next longest number is that one, and finally we have one of those. Now this looks like the one in problem 5, except that the decimal place forces a different stacking. So working from the right, 4 and 6 and 6 and 4. 4 and 664 thousandths. That would be the correct way to read that. 8. 1.111 plus 2. I'm writing it down the way it reads from the book, but if you want to stack it up as you write it down, that's fine. So, you know what? I've got this first number stacked in the beginning, so I'm going to just stack the others underneath of it. Now, this I thought was going to come out the same as the one above it, but it doesn't because the decimal point forces a different stacking. Working from the right, 1, 3, 6, 4, and this is going to be 6 is 10, so 10.631, which is 10 and 631 thousandths. Number 9. Now, use lots of space. Mine kind of slopped over to the next line, so I'm going to give it 2 lines at the end. Here's the problem as stated. You can stack it up as you wish, but I'm going to point out something. Plus 0.700 plus 0.7000. I'm going to point out something, and all these trailing zeros don't mean anything. So this is really 4 times 0.7. Well, remember what the rule is for multiplying decimals? You do the multiplication as though there were none. That's 28. And then the number of decimals in the problem should equal the number of decimals in the solution. So that decimal is going to come down here, 2.8. That's the end result. 0.5 plus 0. Again, this is the problem as stated. You can stack it up as you write it onto your paper. I'm going to start with the big, I've got the first one here, 0.55 and 0.555. So I'm going to do this problem right here. All right, 5 at the end, 10, 15, 16. Like that. 1 and 605 thousandths. That's all for now.